if it records. But it'll be. Are you guys looking at my Algebra 2 homework?
Yeah, he did it, and he doesn't know how to do it.
Yes, I do.
He literally got it
To be
wrong.
fair, we did it in September
I didn't finish it.
in here.
I do know how to do it.
Yeah.
You just...
We've done those.
These?
Yes.
You don't remember?
Slant asymptotes, horizontal,
Oh,
vertical.
yeah.
Those guys. That's what those are. But this is solving instead of graphing.
Yeah, because we get ready for
Yeah.
like when they do it.
Yep. That's okay. All right, so we had this definition yesterday. This is our recursive function where it's given us a rule and it's based off the previous value. So we're going to work through several of these, identifying the terms and trying to find a rule for the nth term. And honestly, this one's nth term equation is obnoxious and weird. But mostly we're all about finding the terms because we don't have to do the nth term a ton of times. So I'm giving you a sub 1, and we're going to find 1 through 4. So what we're going to do is we do this kind of like a substitution. I'm going to make it so you don't have to fill my brain. We're going to come in here and we're going to do a sub 1 plus 1. So we're using a k of 1 here to start. So since my k is 1 and my a sub k, they tell us over here, my a sub k is 5. Or actually, I was writing it a different way yesterday, so let me write it the same way. A sub 1. Because then we can substitute this in, and we're going to get a sub 2 equals 1 times 5. What is 1 times 5? 5. Not a trick question. So a sub 2 also equals 5. So then we're going to keep going. We're going to keep filling things in. Now I'm going to do a k of 2. So we're going to have a of 2 plus 1. So now my k is 2. So k is 2 times a sub 2. Which means when we do this simplification, we're going to have a sub 3 equals 2 times 5. So a sub 3 is 10.
So basically, K is just like whatever
Mm-hmm.
the little.
Mm-hmm. The little sub number. Because we have to, when we have a recursively defined function, our next term is based off of our previous term. So we have to have some place to start. I can't just say, all right, what is a sub 20? I don't have any way to know that because we need to know a sub 19 in order to get a sub 20. Like, I need to have the one before it in order to get one bigger. So in a recursive function, we have to have the previous number. So let's get a sub 4, which we get by using a k of 3. So we're going to have a sub k plus 1, 3 plus 1. So our k is 3 times a sub 3. That is an a. It looks like a 9. So when we simplify that, we're gonna have a sub 4 equals 3 times, and I'm just gonna write it this way, 2 times 5. 2 times 5. I don't like that parenthesis there.
Why would you do 2 times 5?
Because I'm trying to get us to see the n term one. It's still the same thing as 10. I'm trying to set us up to see, because the nth term one on this one is super gross, and it's going to be the grossest one we've seen. I just used this, oop, that is not the one I meant. This version of a sub 3 still equals 10. But I'm trying to figure out a way to get it so that we can see this n formula. We're not going to have to write them quite this gross, but the one we have on this one is gross. And I'm trying to get us to see it. And honestly, I don't know of a better way to show it than to write it like this. I'm trying to come up with one, but it's not working well. So our a sub 4 is what? What is 3 times 2 times 5? 30. So if we do this again, like if we don't spot patterns right away, we can always do a couple more. Because we want to try and write one so that I could find a sub 20 without having to do all the things in between. So I'm going to do another one, and that might help us spot it. So let's do 4 plus 1, which is 4 times a sub 4. So,
In a sense, we're just substituting whatever we get in the previous one.
yes. Yes. That's all a recursive function is we're substituting our previous one in. We're just trying to see if we could spot a pattern so that we could put an nth one in. So I'm going to do it the same way, where I'm going to use the one from above. So we have our 4 times, and I'm going to use this guy, 3 times 2 times 5. And in fact, if I had included this 1, it might make it a little bit easier. Do we notice a pattern here? What is it when we multiply a number times all the numbers after it? Do you guys remember? It's been a hot minute since we used them. Not quite. Huh? An F. Back. It's always very exciting because it uses an exclamation point. Isn't this 4 factorial? And this one is 3 factorial times 5. 4 factorial times 5. This one is 2 factorial times 5. So honestly, that's the only reason I wrote these out as separate multiplications here. Trying to notice this off of the value there is almost impossible because we do not have factorials memorized, nor do we need to have factorials memorized. So the way we could write an nth rule for this so that we wouldn't have to do it as a recursive function, we could get this for any value. We're going to get a sub n is whatever. See how this number was a 5? We used a 4 here. It's n minus 1 factorial times this 5. This 5 is constant in everybody. Times 5. So again, we're not going to be spotting factorials frequently. Like that is not going to be a common thing. It's one in this one, but it is not a common piece in recursive functions. It's just obnoxious. But this is one that they wanted us to do in our examples. Okay, So yeah, again, we're not going to have a ton that have factorials. In fact, I think this might be the only one that has factorials in it. But it's possible for them to show up every now and then, so I wanted to make sure we saw that and how we see that. So if you're not spotting a pattern, go back and write it out long form. It might be easier to spot a pattern if we write it out unsimplified. Okay, let's get into something a little bit less gross. Pretty much, I just thought of the way to say it. The only time we're going to have a factorial is if we're using our base as a term. If our base, like that sub number, is a term, then we're probably going to have a factorial. If k is involved in our multiplication. It's not often. In fact, I don't know that I've ever seen k used as a product in our multiplication before. But so if we use that base number as a term in our rule, that's when we could probably have a factorial. Okay, so this one's a lot more normal. So we're again going to be finding n's 1 through 4, and then we're going to try and write a function rule that makes it no longer recursive. Because remember, a recursive function is looking back, and it has to be looking at the previous number. We don't want to have to look back, because I don't want to have to, if I ask you for the 50th term, I don't want us to have to do 1 through 49. I want us to be able to just plug and chug. So we're using our first 4 to see if we can spot the pattern here. So we have our a sub 1 is 128, and our rule for our recursive function is that to go up 1, to do k plus 1, we have 1/4 times our previous value. So to get a sub 1 plus 1. We always start with the term that we're given. So I know 1. So I'm going to use my k of 1. That's going to be 1/4 times a sub 1. Or a sub 2 is 1/4 times 128. Oop. So what is a sub 2? Mm-hmm. So then we're going to do the same thing. A sub 2 plus 1. We're going to have 1/4 times a sub 2. So we're going to have a sub 3 equals 1/4 times, and I'm actually going to do this like I wrote on the last one. I'm going to write it the way we had it up here. 1/4 times 128. So I'm doing it a little bit differently. You can absolutely use the simplified version. I'm just doing this because it's going to make our pattern spotting easier. So you can either do this as 1/4 times 32 or 1/4 times 128. So what is a sub 3? 8. So let's grab a sub 4, and then we should be able to spot our pattern, especially if we write it down this way. So we're going to get our a sub 4 from using our k of 3 plus 1 equals 1/4 times a sub 3. So that means we're going to get a sub 4 as 1/4, excuse me, hiccups, times this guy. 1/4 times 1/4 times 128. Or you can, to do the calculation, you can do 1/8 times 1/4, or 8 times 1/4. Helps when I say things right. So a sub 4 has a value of 2. How could we write our pattern for a sub n? For our any term. Make this not recursive. Look at our patterns here. What do we notice? We're dividing by 4 each time. Absolutely right. So, looky here. How many 1/4 do I have in this one? 1. How many 1/4 do I have in this one? 2. How many 1/4 do I have in this one? 3. So we're taking 1/4 times itself how many times? N minus 1. And every single one of them is multiplied by 128. So I know it's obnoxious to write them out like this, but it sometimes makes spotting the pattern a little bit easier. It's absolutely valid to just put in our 32, our 8, and multiply it that way. It'll get you the right values, but writing them out like this makes it easier to spot the pattern. Unless you're like really good at spotting the patterns. Not necessarily my strong suit. Okay. Questions on this one? So I feel like this is more in line with what we're typically going to be doing. This is a lot more in line with what we're normally doing. The factorial one is obnoxious and annoying and weird. This one is a lot more in line with what we're going to be doing. Okay, so the next one just says to find the next 3 terms. We're not finding an n term on this one because this is a double recursive function sequence. It requires us to have 2 pieces that we know because they're having us solve for a sub k plus 2, and we also have to know k plus 1, and we have to know k. So this one requires 2 values for us to know. So we're just finding the next 3 terms. So we are going to find a sub 3, we're going to find a sub 4, and we're going to find a sub 5. Those are our goals. We need the next 3 terms. These are the next 3 terms. 2's here. They tell us to. I'll write it down over here if it helps. Whoop. So a sub 2 we already know. A sub 2 is 7. So what we're going to do is I'm going to start, whenever we're doing one of these, I'm going to start with the earliest one we see. I know a sub 1, so that's going to be my first k that I use. So I'm going to come over here and we're going to use a sub 1 plus 2. And that's 3 times a sub 1 plus 1 minus 2 times a sub 1. So we can also write this, simplifying these out, as a sub 3 equals 3 times a sub 2 minus 2 times a sub 1. So it's using the pieces we know to find a piece we don't. So then we're going to do those substitutions. A sub 3 is going to be 3 times a sub 2 is 7. We were told that. minus 2 times a sub 1, which is 4. So 3 times 7 gives us 21. 2 times 4 is 8. 21 minus 8 is what? 13. So a sub 3 is 13. Actually, no, I'll just do that. There we go. So we're doing substitutions in what feels like a very strange way. This is oftentimes actually how our brain does math when we're doing mental math. We're substituting in values we've previously known. It's just really super awkward to write down. It feels foreign. And that's okay. So let's do a sub 4. Same thing. I'm going to take the next one. We did a k of 1 here. So now I'm going to do a k of 2. So I'm going to use in every place we have a k, I'm going to use 2. So we're going to do a sub 2 plus 2 equals 3 times a sub 2 plus 1 minus 2 times a sub 2. And I'm not saying you have to write down every single step like this. I just find it really helpful to see where these pieces are coming from. Because we're going to get our a sub 4 by taking 3 times a sub 3 minus 2 times a sub 2. So a sub 4 is going to come from 3 times a sub 3 was 13. 2 times a sub 2 is 7. Oh, and my screen decided to stop talking to my computer again. I wrote the 7. I promise it did. It's coming back eventually. Oh, I love it so much.
Did you make choices that I don't?
There it is. There's the 7. A lot of work to get a 7 looking back. All right. So let's simplify it. 3 times 13 gives us 39 minus 2 times 7, which is 14. So we have a total for a sub 4 of 25. And I'm going to do our last one in that kind of middle space that I left because I made choices. So our last one we did had a k of 2. So now I'm going to use a k of 3. I started with 1, then I did 2. Now we're going to do 3. So it's the same vibe. Same kind of vibe. So we're going to take our a sub 3 plus 2 equals 3 times a sub 3 plus 1 minus 2 times a sub 3. So that's going to let us know that a sub 5 is going to be made of 3 times a sub 4 minus 2 times a sub 3. So a sub 5 is going to be 3 times a sub 4 we just said was 25 minus 2 times a sub 3 was 13. So that's going to give us 3 times 25 is 75. And 2 times 13 is 26. So the value of a sub 5, 49. And we're not trying to find this in terms of n's. We're not looking for a pattern here. We're not looking for additional pieces here. So make sure when we're looking at things like homework problems, we're making sure to pay attention to the instructions, whether or not we need to find that extra pattern. Because we don't need to here, because honestly, it is horrendous. So gross. So we're not going to do that. We don't need to do that when we're not asked to do that. Because it can't always be an equation, and it can't always be in terms of n, and it will be exceptionally gross if you try. Okay? So make sure we're following our instructions on this. We're going to do one more like this. This is kind of double recursive. And it's almost identical. It's almost identical. It feels identical. Except this time we're given an a sub 1 of 3, an a sub 2 of 1. And we're told a sub k plus 1 is 3 times a sub k minus 2 times a sub k minus 1. Oh, so this is our last one for the day. So, like, we're good on time. All right. So my first instinct would be to start with the earliest k that I have, starting with a 1. If we do that, and we do a sub 1 plus 1, 3 times a sub 1 minus 2 a sub 1 minus 1, that's going to tell me a sub 2 minus 2 a sub 0. And I see two weird things happening here. One, I already know a sub 2. I don't need to calculate it. Also, I don't know a sub 0. So we're not going to use a k of 1 here. I don't know this piece, so I can't calculate it this way. That is why they told us a sub 2, is I couldn't calculate 2 if all we know is 1. So we know a sub 2. A sub 2 equals 1. So if it doesn't work, try the next one in the term, or the next one in the sequence. So this one does not work. I'm just going to put nope. So let's do the next one. See if we can make it work there. If we use a k of 2, so a sub 2 plus 1 equals 3 a sub 2 minus 2 a sub 2 minus 1. That means we're going to learn a sub 3 from 3 times a sub 2 minus 2 times a sub 1. Those are all pieces we know, at least on this side. So now we can do things with it and we can substitute it in. We can't always find every term based on what we start with. But we will be able to find something. So we can start with a sub 3. We're going to get a sub 3 by doing 3 times a sub 2, which is 1, minus 2 times a sub 1, which is 3. What are we going to get as our value for a sub 3? Negative 3. So a sub 3 is negative 3. So now we're hitting a groove. Now we're finding values. So let's do a sub 4, which we're going to get by using a k of 3. Give this little wall here. A sub 3 plus 1, we're going to get from 3 times a sub 3 minus 2 times a sub 3 minus 1. So a sub 4 is going to come from 3 times a sub 3 minus 2 a sub 2. So that's going to be 3 times negative 3 minus 2 times 1. So what is the value of a sub 4? Negative 11. I want you guys to do a sub 5. Find the next one. I'll work it through. I just want you guys to try it on your own first. Okay? We've got the time, so we're going to take the time to do it. What did we get? Negative 27. Okay. So they're weird to wrap our brains around. And some of them are extra gross. But once we get the hang of it, they're not evil actively. They're passively evil, not active evil. Okay? So that is going to be where we stop for today. So you guys have time. Again, it's picking a different font. It's so much fun. I love this. I don't remember. It's I think we have at least one more day on 10-1. So I think we start 10-2 on Monday, so Monday, air quotes. Yeah, like it's definitely an entirely different font than what is on my iPad. It is so much fun.